Welcome to the Psychedelia Podcast, where we talk about the third wave of psychedelics. Through our many wide-ranging conversations with scientists, policymakers, entrepreneurs, and event organizers, we bring you an exclusive look into the many minds of the psychedelic world. It's time to let the word out about psychedelics and how they can be used as tools to benefit both the individual and the community. Welcome to the third wave.
Okay, hey listeners, and welcome back to the Third Wave podcast. We're actually doing a slight rebranding, which we'll roll out in more details in an email newsletter. If you're not on our email list yet, subscribe to that, get our newsletter. But we made a team decision to rebrand from the Psychedelia podcast to the Third Wave. And this is just going to be the podcast of the Third Wave. It's a bit simpler and allows us a bit more flexibility with what we're doing. So welcome back to the Third Wave podcast. It's great to have you guys all back again. I'm actually recording this from Amsterdam in the Netherlands. I am here for the Next Web conference, which is one of the leading tech conferences, probably the leading tech conference in Europe. And I'm here to speak about microdosing. I will speak on Friday, May 19. So you guys, if you're already listening to this, it already happened. And so I'm kind of in urgent mode preparing for the talk. It's probably the best professional opportunity yet because I will be speaking about microdosing to a tech and entrepreneurial audience. Most of the talks that I've done so far, the seminars that I've done so far have been to a largely psychedelic audience. I think many of these people at the conference will either be psychedelic naive or curious about psychedelics, maybe know a thing or two, but haven't done it before. So it's a phenomenal opportunity to bring more of the messaging to a new audience. And I'm super excited for that. So a few things for this week in psychedelics. One, an entrepreneur is building a DMT machine to allow communion with aliens. He is looking for tens of thousands of dollars in funding. His name is Egon Ehrenberg. He's a web marketer from South Florida, and he's one of a handful of people who think he's found a new way to contact aliens through DMT. This article is on The Rooster, which is a website that the Third Wave has been featured on a number of times. And like I said, he's looking to raise thousands of dollars. I think it's interesting. I think it's fascinating. I would love to use it myself. So we'll see if he can get the money necessary to make it happen. And this was written by Riley. Hey, Riley, if you're listening to this, Riley's a good friend of mine. He's written a few pieces for The Rooster about microdosing that we've been featured in. So, DMT machine, tens of thousands of dollars. That's really interesting. Fundamental just released their campaign video, fundamental.nyc. They are supporting psychedelic research for mental health through crowdfunding. They're trying to raise millions of dollars for research into alcoholism, into cognitive ability for microdosing, into end-of-life anxiety, and into PTSD. That's the last one. So end-of-life anxiety, cognitive ability, PTSD, and alcoholism. That's what they're trying to raise money for. It's through a crowdfunding campaign. They've done a really good job of designing their website, and I highly recommend you guys go and check that out. A couple more announcements. There's a video review of the Psychedelic Science Conference by Reason TV. Reason is independent media outlet, and they usually have pretty good stuff. I haven't watched the video myself, but if you want to get a fairly objective view of the Psychedelic Science Conference, that would be really cool to check out. And news from Germany, 1P LSD will possibly be illegal in Germany soon, following advice from independent experts to the government. This announcement was translated on the Third Wave Forum. Go check out the Third Wave Forum if you haven't yet, by a German member. Obviously, that's not going to make a difference. You can still order things from the Netherlands and you can still order things from elsewhere. Yeah, it's just silly. Governments are silly. Governments are out of touch. They really don't know what they're doing when it comes to psychedelic substances. So let's get into the show this week. So for this week, we're joined by Zach Mainen, who is a neuroscientist at the Champalimaud Centre for the Unknown in Lisbon, Portugal. Zach is one of 3 research directors. He's been in Lisbon, Portugal since 2007, 2008, and he leads a team of 20 researchers where they basically try to test the role of serotonin in decision-making for rats. And Zach studies the role of serotonin in behavior and learning. He explains what his results could tell us about the way psychedelics work in the brain. And we're also discussing future research into microdosing that could help us understand its true potential. So what I really tried to push Zach on and press Zach on is, okay, when we're microdosing, what is going on in the brain? What's happening in the brain? We know that, for example, psychedelics disrupt the default mode network. We also know that activation of the 5-HT2 receptor leads to plasticity. It also leads to more patience, to impulse control. So when we microdose, what's going on? We tried to come to some conclusive conclusions. I hope that you guys get a lot of value out of this podcast. It's one of the best podcasts. Zach is incredibly informative. We do get a bit abstract at times using terminology from a neuroscience perspective. However, I think overall the messaging is very good. So please take a look and take a listen, and I would love to hear what you guys think about this podcast. A couple things before we go. If you could, please leave a review on iTunes. Thank you. If you enjoy the show, it helps other people find us. And we're on Patreon, patreon.com/thethirdwave. This podcast is 100% listener supported. There will never be advertisements, and I want to keep it that way. But the only way I can keep it like that is if I have enough money to pay for rent and food and stuff like that. So your donations are incredibly appreciated. It would go a long way to helping us continue to carry out this message. So without further ado, here is the podcast with Dr. Zach Mainen. Can you just give some background about like who you are and your professional background and your psychedelic background in whatever context you wish to share?
My professional background, I studied psychology and philosophy as an undergrad, and it was pointed out to me when I was deciding what to do that I would be better off doing psychology than philosophy by both my philosophy and my psychology advisors. But I took that as a statement about philosophy and not about myself. So I ended up I was interested in artificial intelligence. That's how I got into psychology. And I started working in a lab that was a neuroscience lab and decided to do a Ph.D. in neuroscience. And I actually got sucked into a very low-level kind of mechanistic understanding of the brain, or trying to get to a very detailed understanding of the brain. So I was studying things like, how does one neuron talk to another neuron through a synapse? How does a synapse change? What are the molecules that are involved? What are the dynamics of the molecules involved? So really small nitty-gritty stuff. I did my PhD in San Diego, and then I came out to New York to a place called Cold Spring Harbor Lab and continued to work at that level. And then around 99, I was promoted to have my own group at Cold Spring Harbor. And at that time, I was kind of burned out and bored, basically, with that. We kept basically saying, we found this mechanism at the level of the synapse, which works like this, and we're pretty sure that this is going to have really big implications for how we understand complicated behavioral and cognitive processes. But we can't really quite tell what they are, but it's going to turn out to be important. So it was always sort of too far off. And I decided to switch quite radically and start studying behavior. All this work is being done in animals. So this was synapses in animals, because you can't study really synapses in the living state in people.
Sure.
It's just
not allowed yet. Right.
Not allowed. So at that time, I said, what would be I really want to study consciousness or cognition. I want to study, why the big questions, why are we here? Or how does it all come together? It's actually that same time that I encountered psychedelics. And actually, I would recount a particular moment in which I had taken LSD and I was contemplating the experience itself. I was saying to myself, oh my gosh, this is the most profound kind of insight that I've ever had into my own mind. It's amazing. How could it possibly not be true? And then it occurred to me, the only way it could not be true is if the substance itself, this chemical itself, had somehow tricked my brain by sort of pushing the button that says this must be true and important. So if that was happening, then the thought that I was having was not true and important. It was just that I had taken some substance that had deluded me into thinking whatever it was that I was thinking was true and important. But that in itself is interesting, is really interesting. Actually, that idea that there could be a chemical which would interact with something in the brain, which would send a signal of importance, of meaning, of certainty, almost seemed to me more interesting than whatever else I was thinking about at the time. Actually, what I was thinking about at the time, I subsequently mostly forgot about. But this idea that there might be a mechanism in the brain that is central to the evaluation of truth, central to certainty, is basically what's been motivating my research ever since then. So for the last 18 years. And I've followed different threads in trying to address that in different ways. So we've studied, for example, how humans report, or even animals report, their sense of confidence. So when you ask someone to make a decision where there's some degree of uncertainty, you can then ask them, how confident are you that you took the right decision? And they can tell you very confident, not very confident. Animals, even mice, can be asked the same question. Of course, you don't ask them verbally, but you put them in a situation in which they make a decision, and then you ask them to gamble on the result of their decision. They gamble by waiting, and if they wait and the reward that they're expecting is not delivered, then the more confident they are, the more they're willing to keep waiting for this expected but not delivered reward. So it's the same thing that would happen, say, if you were waiting for a bus and you weren't entirely sure when the bus was going to come. If you were really confident that it was going to come, you'd be willing to wait longer before, packing it in and going home. So this idea you can report confidence, you have a sense of confidence. Well, that seems to be something that's not unique to humans. It seems to be something that animals have as well. And we can therefore start to try to understand in a mechanistic sense where it comes from, and perhaps link it to the receptors that are activated by a drug like LSD.
Why is that important?
Example of a thread that sort of takes off from that idea. Why is that important?
Yeah, why is that important to tie the mechanistic to the understanding that LSD or psilocybin could facilitate that?
So the basic goal of modern or contemporary neuroscience is to take the understanding of the brain that we've had so far and to take it to the next level. The next level is to understand the brain as a kind of circuit or a network. So the human brain, as you know, it's of order 100 billion cells, 100 billion neurons. For a mouse brain, it's more like 100 million, and they're organized in a very complicated network. And so we build models. We would like to have a model of those networks in detail that links the single cells, which we understand fairly well, to the global behavior of the thing. So there's a big gap in scale between cells that we kind of know what's going on. We know how a single cell takes inputs, synaptic inputs, basically connections from other neurons, integrates them in space and time, and then decides whether to send a signal to the next neuron or not. They're detailed models. I worked on those sort of models when I was a Ph.D. student, and there's still details that are left out, but kind of think we know roughly what's a decent model for a single cell. So we would like to link that to the level of behavior, to the level of thinking or cognition. But between that scale and the scale of the whole brain, between the scale of single cells and the whole brain, it's very, very complicated. So to understand the effect of a psychedelic on the whole brain or on one's thoughts, one would need a good model of what are thoughts, or what is taking place in this vast network, and how is that being modulated? That's what we're striving for. So, in other words, we can make up whatever theories we want, and I could tell you how I think about it at a sort of top-down level, from a cognitive perspective or from a psychological perspective. But in order to really understand it, the way we're trying to understand the brain, we need to map it onto our picture, our sort of growing picture of what these networks do, how they process information.
So let's go with that angle. Let's go with that thought.
Specifically when you're talking about thoughts, because I think this is an important part of what we're now discovering from a medical application side of psychedelics is I sent you those pieces on like the default mode network, for example, which Carhart Harris has talked about in the research he's done in Imperial. And, there seems to be this aspect, and I don't know how this is related to the default mode network, but people who struggle with depression have a tendency to fixate their thoughts on the past. They have a tendency to become stuck in the past, so to say, to dwell on the past, and that can affect their present moment. So what have you done at your lab? The research you've done, carried out, for example, the piece that you recently published or paper that you recently published showing this relationship between serotonin receptor activation and cognitive flexibility in rats. What are those implications for the thought process and how it relates to the applicabilities of, psychedelics in a medical context?
You've got a lot in there.
Well, you can dig it apart.
Dig
it apart.
Let's leave the thoughts per se out for a second and just talk about, let me just try to address what sort of studies we're doing and what do we mean by plasticity and how might that relate to psychedelics.
Good.
How about that?
We'll start there. I feel like sometimes I just go for the home run. I'm like, I just asked too big of a question.
Yeah, you got it all. You got it all there. Okay, so let's see. The first thing we have to say is, what is a psychedelic? It's more or less defined as something which binds to a type of serotonin receptor, one of about a dozen.
Which one? The 5-HT2A, right?
Yes.
Yeah, I just 5-HT2A.
So 5-HT2A. There's some debate about that at a certain level, but let's say by and large that accounts for a lot of the observations. So what we've done in my lab is to back off and say, well, let's ask, what does serotonin itself do? So serotonin is also something that binds to the serotonin 5-HT2A receptor.
Sure.
And we actually don't know very well what it is that makes serotonin be released in a natural circumstance.
Endogenously. We could say, right?
But it is absolutely the case that serotonin is a very important endogenous transmitter in the brain, extremely important, and that at least in part what it does is probably mimicked by a psychedelic. So would it be interesting to understand what the neurons themselves, the ones that when they get active do the same thing as psychedelics, why do they get active? What circumstances, what can make them more active? So that was the sort of question we had in mind when we started the studies that you're referring to that were published, I believe, in January in eLife. January or February.
Yeah, recently. It was quite
fairly recently. Yeah. So again, working in mice, we were actually picking up on experiments that have been done previously by other groups, notably Trevor Robbins' group had done some important work on this, where they had trained animals. Can be done with monkeys, it can be done with humans, it can also be done with mice. The animals are trained to expect a reward in a particular situation. The situation is signified, in our case, by an odor. It could be anything. It could be a sign on the wall. So a particular trial.
Like olfactory in nature.
Well, it can be any sign. It's anything that's predictive. Okay. So it sets the condition. It sets the context of the condition in which the next few moments are going to unfold. So say if it's a mouse, mice are quite attuned to odors, so it's a very convenient thing to do. If you're working with humans, you're going to probably look at visual stimuli. It's kind of irrelevant, but what's important is that stimulus, that cue, is arranged to always be followed by a particular outcome. And you could use a reward or a punishment, a significant, a salient, a meaningful outcome. So for a mouse, the mouse is thirsty, getting water is really meaningful. So if you repeatedly pair the presentation of a particular odor with a little bit of water later, they'll quickly come to anticipating the water whenever they receive that odor. As has been observed for well over a century, you've heard of Pavlov and the dogs. I'm sure you may have even seen it in your own experience with your own pet, right? So you can easily condition animals to anticipate something. In these experiments, you then play a trick or you shake things up by reversing the association. Okay. So an odor that was previously rewarding is now either simply not rewarded or is now followed by a mild punishment. So for a mouse, for example, it's a bit of a puff of air to the face.
Okay.
So it's quite mild.
Gentle.
Gentle.
We're being gentle with the mice, right? Even though we're going to feed them to snakes later. We're being gentle to the mice.
We're being gentle, and in fact, it's much more difficult to work with animals in a situation in which you have punishments involved. So by and large, we only improve the experiments by not tormenting the animals any more than is absolutely necessary. So this is a paradigm called a reversal task. So the animal has learned, say, odor A is followed by water, and then at some point, odor A is no longer followed by water, and it has to now relearn the association. It now has to not lick. Basically, they normally lick to get the water. If it's reversed, they have now to not lick. You can also play it the other way around. You could take an odor that's reliably followed by nothing or by a mild punishment, and then flip it so that now it means reward, and they again have to relearn. So this is considered cognitively more demanding than just learning the original association, because you now have to sort of overwrite the previous habit, or the previous association needs to be gotten rid of. And it also requires, in a sense, the animal or human to withhold a kind of a normal response. So you could say there's potentially two components. A relearning component would require some kind of plasticity, and a impulse control or a withholding of a response. So you're used to always pushing the button, and now the button is broken and you have to avoid fruitlessly pushing that button, or the sign.
To learn quickly, right? You have to learn quickly. You have to adapt quickly.
So adaptation eventually should occur. You should eventually relearn, but there's a period that animals and people go through in doing this kind of relearning, where they often unconsciously start to show a kind of hesitation to perform the action that they normally would do. So in this kind of reversal task, it had been shown that blocking serotonin receptors can affect the performance of this kind of task. In particular, it makes it more difficult for people or animals to learn to stop responding to the response that was previously effective. And what we did was to follow those up by asking, okay, so what are the serotonin neurons doing normally in such a situation? And that was unknown. So there are very few recordings from serotonin neurons. So we wanted to know what type of signal do they have that might indicate that they really are involved in detecting, hey, something is wrong, what used to be good is no longer good, or what used to be bad is no longer bad. And the key question was actually, do the neurons respond to surprises? That was we generally expected that they would respond to surprises, but is it specific to whether the surprise is a disappointment or a fortuitous, there's no great antonym of disappointment actually, but an opposite of disappointment. So the question is, are serotonin neurons happiness related, or are they just surprise related? Or perhaps the opposite, maybe they're even preferring disappointments.
Are they happiness related, or are they surprise related?
So the reasoning would be, if they're involved in antidepressant actions, which is another drug effect that serotonin is associated with, then they should like positive surprises, perhaps. The serotonin, if it's promoting happiness, should be associated with the transition from something that wasn't good to something that's now better than expected. But this reversal task has both, the way we construct it, has that type of positive surprise, and it also has the negative surprise. What we found was that the neurons don't prefer the positive surprises. They are activated by both positive and negative surprises. They're activated by just being surprised. So they seem to report, at least in part, this is where I make sure I put on my proper scientist hat, where there are some complications and details, and I don't think this is the end of the story, but we overall saw that this actually, and other experiments have led us to the view that serotonin doesn't report or have much to do with the emotional valence of an event, but has more to do with its certainty or its predictability or its surprisingness. And that makes sense in the context of this reversal task, because what we had known from previous work was that if you block the action of serotonin, the animals are not as good at responding to these reversals. These reversals are basically surprises. So if the neurons get excited by these surprises, they contribute serotonin, and that serotonin acts in some way, we don't know yet exactly how, to help the brain change or to help it stop what it's doing at the moment because, hey, I don't know what's going on. I should not do what I normally do. That makes a lot of sense. So at least within the context of this kind of learning experiment, it makes sense and reinforces other experiments that had been previously done. Where one place it clearly leaves things a little bit more complicated is, what about the antidepressants? Why are serotonin reuptake inhibitors used as antidepressants? So that's a big question from our point of view right now. And another question that you could ask is, well, so what does that say about what do psychedelics do? Which is probably the more germane question.
And I want to get into that, right? Because we've been abstracting out of it. We've been using fairly specific terminology.
I'm using a lot of words, and some of them I'm using them very carefully, and some of them not so much.
Right. But this is natural. So I think someone who's a neuroscientist background is going to understand everything we just talked about. Some people who don't might have
so feel free to back off and make me pull some of this.
I want to make it more concrete for people, because a lot of people who are listening to this podcast are interested in microdosing.
Right? Yes.
And we talked about this when we had met, 6 weeks ago or something, when I was in Lisbon last time. By the way, we're having this conversation from Lisbon, just so people know. And what's your professional, you run a lab here in Lisbon, right?
So I didn't
quick say that, and then I'm gonna get the concrete side of things.
No one asked for a linear podcast, I hope.
Yeah.
So to go back to my professional background, I came to Portugal in 2008 to help to start a research institute where I still work called the Champalimaud. Actually, the building is called the Champalimaud Centre for the Unknown. Wonderful name. And the research program is called Champalimaud Research. Used to be called Champalimaud Neuroscience Program. There are about 250 scientists working in the program. And our goal is to try to understand how the brain gives rise to intelligent adaptive behavior, things like decision-making, even a broad range of things going on in different individual labs. Some labs study different parts of the brain, others different transmitter systems, different species. So there's quite a diverse bunch of research going on, and I'm the one of 3 overall research directors, and I have my own group. That's 20 scientists in my group that's more focused on serotonin and decision-making. And I also oversee the work going on more broadly.
Cool. Okay. So let's get into the concrete, the microdosing thing.
Microdosing.
And yes. I'll just try to summarize kind of what some things we've spoken about so far. So, for example, which serotonin receptor did you study with this research? Was it the 5-HT2A or was it all 13?
In the work that I was talking about, what we did was, I didn't explain this. We used a technique that involves genetic engineering to optically monitor the neurons themselves.
Okay.
Not the receiving end where the receptors are, but the sending end.
Gotcha.
So most of the serotonin neurons that are relevant for, let's say, the effects on cognition are located in a part of the brain called the dorsal raphe nucleus.
Okay.
When you get into areas of the brain, you get all sorts of lovely names.
Sure.
That's by no means the worst. So by introducing genetically engineered, actually a virus, introduce a sensor into the set of neurons, specifically the serotonin producing neurons, this allows us to visualize when they get activated by looking at basically the amount of fluorescence that they're emitting. They're basically changing the way that they respond to light. And that gives us a signal of when they're on and when they're off, basically when they're firing or when they're not firing.
Gotcha.
So it doesn't tell us which receptor they were activating. That is, they get activated, they therefore are firing, they therefore can be releasing serotonin, and then that can be picked up by both serotonin 2A receptors, serotonin 1A receptors, and all the other receptors. So we don't actually know. Those receptors could be more or less activated by the events that we're recording. That's another step. actually.
Gotcha. Okay, so let's tie this into microdosing, and we'll try to speak in more concrete terms in terms of there's an individual, or like I've done microdosing. A lot of people are interested in microdosing. They're taking this, it's activating the 5-HT2A receptor or something of that nature. We don't have the research out on it yet, though, in terms of why it's working. It's clearly, it's doing something, and it's been working for a lot of people. There could be a small degree of it that is relatable to placebo, but there's obviously some mechanism that's going on. And if there's no mechanism going on that people can see, then you just need to take a little bit more, I think, because, what's the difference between 10 micrograms and 100 micrograms of LSD? Something's going on at 100. Something must be going on at 10. Especially.
Are you referring to something must be going on? It's not just placebo?
Correct. Correct.
So
yes.
Is there some thought that it might be a placebo effect?
I think some people, you have some of the more, like David Nichols, for example, who, David has led a lot of the research on rats as well in the United States from out of Purdue. He has said to Jim that, maybe some of it could be placebo. I was talking to someone else who's doing research with microdosing with older people, and there was some mention there. There is a somewhat of a placebo effect with this going on, which is natural for depression, for example.
Yeah,
right?
I was going to say that it seems that a lot of, there's a very strong effect, placebo effect in depression.
Sure.
Doesn't necessarily mean that the serotonin effect is not.
Exactly. Yeah, you can have both, right? It's not. It's not
so
one
there
or
may
the
very
other.
well be.
It's not one or the other, right? But this is what we get into, like Dr. Bruce Lipton, who wrote this book, The Biology of Belief, right? If we accept that the mind and the body are connected, then our mindset, our view on the world, also then dictates things like what happened on a cellular level with like quantum mechanics. So we're not completely separate. Even if there is some placebo effect, the intention or the purpose behind why someone is microdosing might be just as important as to actually taking the substance itself, because you don't take things within a vacuum. There's always environmental context in which you're taking a substance. Even with psychedelics, the difference between taking in a room at Johns Hopkins with a professional therapist, you're going to have more healing through that process than, most likely, than doing it when you're 19 after a couple beers with friends in the basement of a fraternity house. That's what I did, and it was an okay experience, but it wasn't that impactful. We have these scale of things. So this is what I think about with microdosing. Anyway, let's kind of get back to the main question. Based on your research with, what's going on in the serotonin system, and based on your understanding of microdosing, what do you think is happening with people from like a neuroscientific perspective?
There's so little that, at least that I know, about studies on microdosing that it's a bit of a challenge to start speculating in the absence of data.
I want to say speculation leads to questions. Better questions lead to better answers. Or they can.
Okay, sure, yes. So what would be our hypotheses?
Hypotheses. Let's not speculations, hypotheses.
So let me so to answer that question, let me tell you another story about another paper that we published in the last couple of months that's also related. So this one is actually a bit simpler. So we did a really, really simple experiment with mice again. We put them in an open field, basically an arena in which they can run around. And we kept putting them back in the same arena every day for several weeks. And we just measured their pattern of movement. And they run around. They tend to stick a little bit to the walls because they're a little bit afraid of an open environment. And they don't really have anything to do. There's no food or stimuli in particular. There's just this box. And then we started stimulating serotonin neurons. And we would stimulate them in a brief pulse, so a few seconds at a time, intermittently. So a few seconds and then wait and then a few seconds. And then we looked at what was the effect of that on their movement. And the only effect that has on the movement pattern of the animals, at least as far as we've been able to see, is it slows them down. So they may be going at an average of, say, 5 centimeters a second normally, and when the serotonin is turned on, it's 2.5 centimeters a second. So it's a pretty big effect. If you put animals in a more constrained task in which they actually have to slow down, they have to wait. You could do this by making them wait in a particular location before you give them their water. Serotonin stimulation also facilitates their kind of waiting. It makes them less jumpy. They're less eager to get on to the next action, and they make less impulsive choices. So that kind of result, that serotonin stimulation seems to reduce impulsivity, has been made by a number of groups. And there's a couple other experiments that we've also done that I don't think I need to tell you about that reinforce that.
Okay.
So one of wasn't our hypothesis, but what the data is telling us from our experiments, from a bunch of other experiments, is that somehow serotonin has a role to play in, let's say, patience, or some people could say impulse control, like preventing impulsive responding.
This is the term that people are using with microdosing.
Okay, so I was not even aware of that.
Exactly, and I know you're not. Yeah,
okay.
This is interesting. Yeah.
So we have now two things that I brought up from our research. One was this role in plasticity and related to reporting surprise.
Sure.
And the other was something about impulse control and, if you want to call it, patience. So it wouldn't be immediately obvious if you're thinking about psychedelic effects to think about patience, or at least for me, it wouldn't be obvious. But as a hypothesis about microdosing, that would be what I would like to look at in, say, if I was doing a human study, I would like to see if I could detect an effect of microdoses of a psychedelic on the performance of a task that required impulse control. So maybe if there's more known, so anecdotally, is it the case that microdosing is associated with an increase in patience? Yes. So this could be very useful for people to avoid falling into habitual responding, falling into patterns of behavior that are, natural responses, or say learned responses to a particular situation that happens over and over again. Those are the type of responses that we think are being inhibited by stimulation of serotonin, and could be part of the action of these low doses of serotonin agonists. There's still clearly a gap in our understanding between what's going on in the natural situation, or when we stimulate with this fancy technique in mice, versus what's happening with a particular drug that you're taking, right? So there's certainly a lot of speculation there, but that seems like an interesting possible connection, maybe tapping into that aspect of serotonin function. The other function, plasticity, is also a possibility, right? So going back to the study with mice.
Well, let's dig into that. Before what is the relationship we know so far about psychedelics and neuroplasticity?
Well, I can answer more easily about serotonin and plasticity.
Okay, let's do that. Serotonin and plasticity.
So as you know, serotonin has been better known as an antidepressant, or, as sort of the happiness molecule.
Sure.
But for the last, even now, a couple decades, there is a line of research that has shown that serotonin seems to promote certain kinds of plasticity in the brain. And when we say plasticity in the brain, usually what we mean, what neuroscientists are talking about, is some kind of synaptic rearrangements of the type that happen when you learn something. And you can study that in different ways, behaviorally, like in this reversal task, that evidence that I was discussing before, that increasing serotonin helps reversals, or decreasing serotonin hurts the ability to do reversals. There's also evidence at a physiological level. If you look at how synapses between pairs of neurons change, or pathways between sets of neurons change, seems to be an effect of facilitating a kind of unlearning process. So there is thought to be a process for making new synapses or strengthening existing synapses, which we call potentiation, and then a process for erasing or depotentiating synapses. And there are several studies that have linked serotonin to the depotentiation, or the sort of losing synapses.
Like SSRIs, people consuming SSRIs.
These studies at this level are animal studies with agonists of serotonin or antagonists of serotonin receptors in very reduced, reduced preparations.
It depotentiates.
It seems to be promoting what we call long-term depression, which sounds bad, but is not necessarily bad. But you could think of it as what needs to happen to get rid of, to allow new pathways to be formed. It's sometimes necessary to get rid of old ones, or to just basically keep everything in balance. You may not be able to constantly keep increasing everything, just building. Sometimes you need to clean house and unbuild before you can rebuild. So that at the cellular level, there's evidence that ties serotonin to that function. And there is another particularly, I think, interesting, important study that showed serotonin is important or can open a window of plasticity for what is a developmental process. So there's certain processes that as your brain is wiring up, or you could say as you're going through childhood and adolescence, which is when a lot of your brain is wiring up, parts of the frontal cortex are still not completely wired until you're through adolescence.
Sure. So like 25?
Something like that.
Sure.
I could put too fine a point,
number
on it.
But generally,
but certainly through teens and,
absolutely.
And very likely into the 20s. Of course, these things vary from person to person, but there's a lot of plasticity going on that will later be tuned down, right? So part of the reason that you can't learn a perfect accent in a foreign language, or not without great difficulty when you're in your 30s, but you can when you're in your lower teens, has to do with some type of plasticity that is not there later on. If you have one eye shut, so if you grew up with an eye problem, there's a critical period for your visual cortex developing proper wiring. And if you go through that entire critical period with your eye not seen properly, it's very hard to reverse that process later. It's much easier if you do it while you're still in the critical period. Sure. So it turns out there are critical periods for all sorts of things, and they vary, and we understand something about how they work at the cellular level, at the molecular level even. Okay. And it was shown by a group in Italy, lab of named Maffei, that serotonin, it can reopen a critical period for plasticity, particularly visual plasticity in their case. So basically you have an adult animal that would normally never be able to recover normal function. When you activate serotonin, I believe it's not the 5-HT2A receptor, but I'm not sure if I would go down that road too far. But so that's why I like to talk in terms of serotonin more generally, because a lot of times we're not completely sure on the molecular level what's going on. At any rate, the window for plasticity is reopened. So it's on several different examples I've given at different levels of analysis that serotonin seems to have something to say about causing, enabling a type of plasticity. So one could easily imagine that microdosing affecting those functions.
Absolutely. So making people more open, making people, maybe it's easier to learn as a result of that. It's easier to learn language. It's easier to access flow states. I mean, these are the self-reports that we're getting from people. There's a guy, Stephen Kotler, wrote this book, Stealing Fire, all about accessing flow states and the different tools that we can use. And one of them he mentions is microdosing, in terms of like possibly reopening these aspects, if we get to a neuro level, like these aspects of plasticity. And so you have someone like myself who's now 26, where it's tremendously helped with the synthesis of different, learning parts. I mean, this is the bedrock of creativity, right? It's divergent thinking. It's taking different ideas and finding ways to put them together in which other people hadn't thought of before. This is an aspect of plasticity. We could say it's something that results from plasticity. And since we're seeing these results when people are microdosing,
I see. So it's interesting to talk about creativity or these processes. I think that's another angle. So when I think of plasticity, I think when you're in a situation, how ready are you to adapt to that new situation? So you could think of learning a language or something like that. You could think of moving cities. You could think of having a change in your personal. Basically, I think about adapting to a change in context. When I think about creativity, I think more about, say, having a particular model of how things are or a particular way of thinking. And I think creativity involves juggling or reconfiguring your model, accessing alternative ways of seeing things. Now, if you had more of that, more flexibility of your way of seeing things, that could certainly help you to adapt, but one isn't necessarily required. One could imagine plasticity without creativity, sure, say, or creativity without plasticity.
Sure.
So I don't know whether, I would imagine this is exactly the sort of thing that we would like to get out of our studies on serotonin. We start with a whole bunch of effects, say, caused by this one molecule. Probably psychedelics activate a certain subset of those effects, particularly interesting subset. But even within the subset of things that are activated by psychedelics, there may be several different components that have different interests for different people or different situations, right? So it's this we're kind of going back and forth between we always want to make finer distinctions and not lump everything together and be careful about associating things. But we also, of course, want at some level a holistic understanding. As you can see from, the experiments get very detailed, and we haven't barely even started talking about the different parts of the brain and how they might be involved differentially in different aspects of things. And a lot of this we just simply don't know. I can't really tell you which part of the brain and which receptor for this thing and that. The research just hasn't really been done. So there's a level at which there's a lot of work to be done to connect the things that we know clinically or anecdotally from experience about psychedelics to what are they actually doing in the brain. And then part of that is just because we don't understand how to think about the brain all that in great detail. I mean,
we're still in the infancy somewhat of understanding the brain, right?
We really are.
With microdosing, you mentioned, and I just want to say something about that. You mentioned this difference between creativity and adaptability, more or less, right? When you can adapt quicker to a situation, we're seeing this research with serotonin, and microdosing seems to be helping with that. It's like Jim Fadiman contextualized it in that, that jerk at the office that you usually have to deal with. They seem to be just like a little bit less of a jerk, basically, where you're just more patient with them. You don't have as much of a reaction. There's more impulse control in that as well. And that's different than creativity. At the same time, if we're using terminology correct, it seems like adaptability could also be related then to, for better lack of a word, natural selection, or the ability for the organism to survive, whether that's as an individual or collectively. So then my question, and you don't have to answer this necessarily, but want to think about, what role does microdosing play in transhumanism?
I thought you wanted to go into something like transhumanism. Before we get there, I think that the evolution perspective maybe is an interesting one to give people an idea of how I was thinking about this. So for animals to adapt evolutionarily, the first thing you think of is some sort of selection process, that the ones that are fit survive and the ones that are not fit don't survive. But in order for the process of evolution to work, there has to be a variation component. That's, I think, the classical term. Variation in the phenotype, variation upon which selection can act. So if you think about evolving better behaviors or better ways of thinking or better cognitive strategies, you could also think in the same terms. So you need ideas to be generated, perhaps, say, variability to be in your thinking, creativity, if you will, on which then selection could act. And selection could be an internal process of critiquing your own ideas, or it could be an external process of actually trying them out and finding out which ones work and which don't. And of course, to some degree, both of those things happen. So if microdosing affected creativity, that in this way of thinking, that could feed into the process of evolution of ideas by generating more material on which selection could act. So it need not necessarily generate immediately better ideas. It could simply generate more divergent ideas, and that would open up perspectives, open up hypotheses that would not have been accessed otherwise.
And I think
so it need not be, could be neutral. It could generate just as many bad ideas as good ideas by loosening the grab of the current thing. So imagine a species that's reasonably well adapted to its environment, but lacks the ability to mutate. Now the environment changes and the animal, the organism, the species is stuck. Only by generating mutations will it ever get out of being stuck. So mutation is always a dangerous sounding thing, and it may actually be bad for the individual, but many of those mutations will lead to failures. But one of them may lead to a much better solution. So that's a fairly obvious, I think, metaphor to think about why that type of randomization might actually be beneficial for the species, or even for someone's individual's thinking.
So I want to tie that into a practical level in terms of, if through this process we're able to generate more ideas, and that means we'll have, I don't know if a standard deviation curve is appropriate, but you'll have something where you'll have a lot of okay ideas, you'll have a lot of maybe bad ideas, you'll have a lot of good ideas in terms of, and we can define bad, neutral, good by what works in the real world to maybe accomplish a certain objective or do something. And so in the past, it's been very hard to get feedback in terms of whether an idea is valid or not. Meaning that if you wanted to start a business, you would have to invest a lot of capital initially, and then you would eventually be able to, quote unquote, validate your idea from a business perspective. And the way you validate it is, of course, are people buying it? Or a nonprofit, are you getting donors, right? Whatever it might be. Business is changing dramatically now, and the ability to test ideas is changing dramatically, where it's much, much easier and it's much, much quicker and it's much, much cheaper to be able to validate ideas in terms of whether they're good, they're neutral, or they're bad. So it seems like, well, yes, you're getting more ideas generally because of whatever you want to call it, technology or the internet, because you have the ability to validate them faster and decide which ones work and which ones don't. Essentially, you generate more good ideas over a period of time, which will, if you have them in line with certain ethicals or principles or values, then that leads to a better world potentially. And so my question, and I think and I don't know if I'm asking a question necessarily, just thinking out loud, but I think from my perspective, that could be why microdosing is really interesting, because if we have the foundation or the context from which people are taking this and they are noticing these benefits, they're able to generate more ideas as a result. And if more of those ideas are good and they can actually carry them out, does that help to accelerate change on a faster pace to address issues like ecological crisis and food crisis and water crisis, all these things that we're dealing with as a species? Maybe. I don't know. Maybe I just I probably took a lot of leaps there. You're probably thinking, Paul, those are way too many leaps. From a big picture, I'm trying to contextualize the practicalities of microdosing. Those are things that I think about.
Every substance has perhaps its role to play. I mean, opiates are a terrible scourge in Middle America, but they're an incredibly useful medical tool for people that are in severe pain.
Sure.
So I have no doubt that low doses of that microdoses can be very useful in certain circumstances and probably will work better for some people than for others. It's rare that there's a drug that is going to be good for all people in all circumstances. And the way I think we should approach it is to encourage research and to try to identify better, to understand better what the specific effects are. So does it really affect creativity? How do we measure that? The work on creativity is a little bit less grounded than, say, on plasticity, because it's very easy to measure plasticity, and it's not so easy to evaluate creativity. There are tests designed to measure creativity, but even on their face, it's not so obvious how you even do that. But I'm open to the possibility that that's one of the effects. I think that if it is the case that microdosing accesses those sort of effects, then your argument would be that because it's easy to test ideas, then we would be okay with the sort of more liberal generation of ideas, even if some of them are crazy. That seems reasonable. The thing that you said that I guess maybe concerns me a little bit is the fact that we can test ideas quickly is potentially a good thing, but what criteria do we want to use to evaluate ideas? It's not completely obvious that the ones that gain more investment dollars immediately or the ones that gain more clicks or what have you are the ones where our long-term interests are actually going to benefit. So I think the problem with climate change, with environmental destruction, is exacerbated by the fact that things are fast and feedback is fast and companies are more encouraged to take quick decisions and do what's good enough for now. And there's some benefits to that, but without some critical faculty of, say, long-term thinking, or without people who decide that what's valuable is not just what happens to my company today, but to my grandchildren or to other species, it's long-term thinking that we need. So if serotonin promotes patience, if not taking the short, immediate payoff and being able to withhold from responding for that carrot or that drop of water or that buck, if that were something that serotonin or microdosing improved, made people less overwhelmed by the reward structure of their immediate environment, even if it had nothing to do with creativity per se, that could be a big benefit. So I think you may know more than me. I'm sure you know a lot more than me about the topic, but the creativity aspect is one thing, but I don't know, maybe that turns out it's a figment of your imagination because, people report all kinds of things. I don't know, maybe it works for some people. I think we need more experience, compared to the amount of experience that, the amount of research that was done on full-blown psychedelic effects and the number of trips that have been taken. I think that what we know about microdoses is much less still, right? Maybe it will eventually reverse.
Eventually, and I think
seem to be
right now
safer, easier,
sure,
more approvable, etc.
Sure.
But I wonder, for example, maybe I turn the question back to you. Like if a dose is one thing and a microdose is the other thing, what differences is a microdose simply 1 tablespoon of a full liter of full psychedelic experience, or is there some important way in which a microdose lacks some positive or negative or whatever aspect of a full experience? Yeah. Is it just like spreading the same thing out over more days?
Yeah,
how do you think?
I think you have to look at them as two mostly separate things and ideas, microdosing and we could say macrodosing, where of course you're taking a psychedelic, but the experience that you're going through, whether from a snapshot perspective in terms of when you're under the influence of the substance, or whether from a long-term perspective when you're integrating that, it's different. So microdosing is non-threatening. Microdosing is usually 1/10 of a regular dose, is kind of the quote-unquote standard or typical amount that you would say. If a standard dose, for example, of LSD is 100 micrograms, a microdose might be 10 micrograms. And a microdose is just very subtle. I like to have a more general perspective in that it's an amount that you take where you don't really notice anything that's too different, but things are a little bit better. And over the period of time, maybe 2 weeks, 3 weeks, a month, 2 months, you're a little more patient, you're a little more mindful, you have a little more energy, you're a little bit more engaged in relationships. And it's not a one-time snapshot thing like I think the high doses of psychedelic. A lot of that has been what is the actual one-time 3-hour, 6-hour experience like? And although there is obviously follow-up on how they've integrated it, a lot of it, crux of it is the experience that the individual went through and what effect it's had on their life. Microdosing, it's not 3 or 6 hours, it's a month, it's 2 months, it's 6 months. And I think for me, that's the biggest difference that I see.
But within that difference, do you see there's a big difference in the strength of the experience and the time window? But do you think that it's essentially the same thing spread out?
No.
What hypotheses, what would you invoke as what's recruited by a full dose that's not?
The mystical experience. Having this sense of oneness, having this sense of unity, this sense of transcendence, this sense of, we could say, non-duality. What we spoke about earlier, what got all these Buddhist thought leaders into Buddhism was psychedelics, because they had a mystical experience. They had a spiritual experience. This is what happened to Sam Harris in Nepal.
So do you think that the microdosing experience...
The microdosing experience is more physical in nature, we could say, quote unquote. You could tie it to a certain, what you're saying, mechanism that's going on. With macrodoses, I don't know if it's completely mechanistic. I think there's an aspect of maybe an unexplainable thing to it. George Greer, do you know George?
No.
He's the medical director at Hefter Research Institute. I quote him in some talks that I do about, basically he did this Ask Me Anything after they released the results of the NYU and Johns Hopkins psilocybin assisted for, end-of-life anxiety and depression. They released those studies. He did an Ask Me Anything on Reddit and basically said, we don't think that high doses, it's completely biochemical. We think there's an aspect of having some sort of spiritual shift or change that's part of the lasting effects of this treatment. So I think microdosing, I don't know how lasting effects that people will get from microdosing, particularly people who struggle with depression. I think the more lasting effects are going to come from higher doses, where people go through this really intense, rigorous experience that results in some sort of mysticism or unity. I perceive it as becoming more popular, like kind of in the same vein that CrossFit has become popular, where people are willing to put themselves through hell, so to say, willing to take that risk because they recognize the utility and the benefit afterwards. CrossFit isn't fun. It's not really enjoyable.
So are you talking about being more popular now, full-blown psychedelic experience?
I think so. Once we can, in the public's mind, once we can significantly tie the benefits to the actual experience, people will be willing to go through the chance of having a bad trip
or a challenging experience to access these greater benefits over a long period of time. Because there are significant benefits to them. And if you can create that from a cultural perspective, then you solve one of the major problems of psychedelics, which is that in order many times for people to heal from psychedelics, they have to want to do them in the first place. Meaning if you give someone who doesn't want a substance, they're going to have a bad trip. They're going to have a bad experience. That's going to make them even more unlikely to want to do it in the future. So how do you provide a culture? How do you create a culture in which more people are willing to accept the fact that psychedelics can help them? I think that's the biggest question that we need to answer, because you can have all the research in the world, but that really doesn't, it convinces, like I said, it convinces well-educated people with PhDs and masters, but it doesn't convince people who live in rural areas, people who are naturally irrational and illogical. You need something else to do that. And you need to tap into like a more emotional thing rather than, I think, a purely intellectual thing. You need the science. So you need that as a foundation, but I think at some point it requires conversations, and it requires speaking to them on where they're at instead of where we are.
Yeah, I think you've said a lot of things. And I think what sticks in my...
It's hard for you because you're like...
What sticks in my mind... Yeah, where to shoot.
Yeah.
What sticks in my mind is, if I just think in terms of plasticity and, let's say, we like to talk about priors, but you could think of prior expectations or the way you think about things before you get any evidence about how they really are. That's a prior. If those priors go down and plasticity goes up, that seems to explain elements of a full-blown psychedelic trip, and it seems to explain elements, maybe not all, of what you've described with microdosing. And it also may explain most of what's going on with SSRIs as well. So the ability to basically adapt to new circumstances, the ability to break out of old patterns, the ability to get over depression, you know, have to break some bad habits of thinking or some, really stuck way of approaching the world. So maybe these things are all actually tapping into something fairly similar, but acting in different ways. SSRIs have their weird 3-week time scale to act, whereas microdosing takes effect immediately, and full-blown trips, or at least some aspect of it takes effect immediately. Are they all doing more or less the same thing in different ways? Is the end of it that you need to rewire your brain, basically? Seems like a reasonable hypothesis.
It does.
And then if that's what you're primarily doing, no more happy pills, no more... not necessarily even like seeing the truth or the light, but rather just being open to seeing what is already there, which can sound a bit spiritual, could be a bit spiritual in some sense, but it's opening you up to the context. It's opening you up to your actual situation or your current situation, which means that's going to be incredibly important. The context of the therapeutic situation, or the context in which you take them. It's kind of the oldest platitude about psychedelics, set and setting. It should also be true for microdosing. It probably is also true for SSRIs. If you take these things in the wrong circumstance, they may very well lead you even into a worse pit than where you were before. So that all makes a lot of sense, I think. And then in thinking about this kind of context, how do you provide the right context? I know from previous conversation we've had, you think in terms of a change in culture. I think that's very interesting. I guess you could step back and even just say, well, like sort of from a medical perspective, or from a from a more modest perspective, what's the best way to, if it turns out that governments are willing to legalize these drugs, which they ought to rationally, like there's really no good case for keeping these substances in the kind of schedule where they have absolutely no purpose. It's completely non-scientific, non-evidence-based policy. So if that changes, it still kind of leaves the question of how you set the right context for using them correctly. Because if it's not a happiness pill, it's not like you just want to give a prescription to somebody and say, go home and take this. You really probably don't want to legalize psychedelics and let people just start partying with them. Some people that will work fine, but for many people that will lead to real problems, right? Sure. And the medical context is not generally set up very well to deal with this. What I remember reading about Trump's, proposal for healthcare was to cut mental health services entirely from, one of the programs. I don't remember the details, but, mental health services, kind of important, something that's been messed up for a long time. We used to lock people in institutions when they were messed up. Now we lock them in prisons when they're messed up. So the right way to deal with it doesn't end with getting the substances available. It only sort of begins. Then what are the ways to do that? In the absence of a full-blown cultural shift, are there reasonable ways to build contexts in which people can get better? Sure. Whether maybe it's a type of doctor, a type of psychiatrist, or a type of psychotherapist that becomes adept at working with these things, we probably need that. For other people, it may be a more religious context or more spiritual context. It's hard to see it being one thing for all people. So I'm not really sure if you're ever going to see the average Midwesterner going for the same type of spirituality that let's say the tech billionaire goes for, or the Upper West Side lady goes for. They're different cultures. So I don't know if it's necessary to have everybody going through the same thing, but this kind of context is kind of important and rather missing from many people's lives. That's the sort of hole that religion used to play, and the sort of downfall of religion has positive aspects and negative aspects, and the negative aspect is something that you have to acknowledge.
It's like a lack of meaning in a way, and that meaning has been replaced with materialism.
Yeah, and materialism, religion provides meaning in a cultural context with, a group of like-minded individuals who believe in the same myths that you believe and believe in what's meaningful and not. And by and large, those myths are harmless for society and very good for the people who believe in them. But religion has a tendency to take over aspects of society that it ought not to take over. And when that impinges on other people who have different beliefs, then that becomes a problem. But then we get rid of religion and we're left with materialism, which provides no meaning and leaves people for injecting or taking whatever they want, whenever they want. It's not a recipe for smooth sailing, right? So I think I could see psychedelics and microdosing as as playing an important role in society going forward, and that being a good thing. But it won't happen unless the rest of society supports that. For some, people will continue. People who have found their niches and can incorporate psychedelics into them will continue to benefit. But it's probably a relatively small fraction of people that can all, put it all together and can reconcile what they read in the newspaper and, what their neighbors think. And it's a very kind of small crack into which you must fit unless you're really deeply embedded in a psychedelic community. That's a relatively rare thing. If psychedelics become extremely popular, what are we going to do? Are we going to reinvent the 60s? Are we going to go through some sort of a huge cultural revolution and subsequent backlash? Probably that's what
we don't want.
That's probably what we don't want. Yeah, it's a bit like the Arab Spring, right? Sure. We're going to throw over temporarily the dictators and then find that they've just come back even worse the next time.
Where can people find you? Do you have
my name is unusual enough that if you Google me, you'll find me pretty easily.
Zach Mainen.
There's a website for my lab.
Okay.
I occasionally tweet, not much. Okay. Zach Mainen, ZACH. MAINEN.
Easy. Well, thanks so much for doing this. I really appreciate your time.
Thanks for having me.
Okay, we're now back with questions. So we're back with questions. We had the intro. We talked about this week in psychedelics, and we had the podcast. I really hope you enjoyed it. If you did enjoy it, please leave a review on iTunes or go ahead and donate on our Patreon page. 3 questions this week from Bu Jaco, from Heather, and from Colin Foster. So the first one from Bu Jaco is can psychedelics do anything for migraines? Not cluster headaches, but migraines that happen once or twice per week. So we have an article about using psychedelics to treat cluster headaches, which we first recommend reading if you guys are interested in these questions. We really don't know with conclusive proof if it would work for migraines also. However, there might be reason to believe that there's a similar mechanism going on with migraines as there is for cluster headache. But we still don't know what psychedelics are doing for cluster headaches. So we're kind of in the dark here. My assumption is microdosing, maybe with higher doses, could help with migraines. If you are struggling with once or twice per week migraines, maybe try out microdosing to see what that goes. But obviously, this isn't medical advice. So if you are having frequent migraines, the first step should always be to talk to your physician about the best treatment options. And I've emphasized this in the seminars that I've done before. I'll also emphasize it now. If you don't feel comfortable talking to your physician about the fact that you might microdose to help with migraines, find a new physician. There's enough research, there's enough anecdotal reports now that show that psychedelics are effective at treating cluster headaches. There could be reason to believe that they're also useful for migraines. And psychedelics are much less toxic than a lot of even mainstream pills that people will take for migraine issues. From Heather, would you say the positive effects from microdosing are only temporary, or can they cause positive permanent changes that last after your microdosing regimen? My assumption is that there are positive permanent changes going on. Sometimes. But like all things, it depends on the individual. So I'll kind of give you some context on that. I think what happens when you're microdosing, the neurotransmitter, serotonin, it's activated by the 5-HT, or it activates the 5-HT2A receptor. And we know that leads to plasticity, neuroplasticity. We also know it leads to impulse control. So if we continue to send that message through microdosing, 2 times a week for 10 weeks, 20 weeks, 30 weeks, there's reason to believe that we might be training the brain to operate in a different way, to start communicating in a different way. And just like with mindfulness meditation, right? We have research that shows that consistent mindfulness meditation actually creates new gray matter in the brain. Now, if you meditate consistently for a year and then you stop meditating for 6 months, some of those benefits are going to subside. Not all of them, but some of them. So it's probably similar with microdosing. You'll start to notice the best benefits as you're microdosing. If you stop for a month, some of them might dissipate, not all of them. But if you stop for like a year, those could continue to dissipate. So I think what's important to emphasize is that it's really helpful to combine microdosing with a meditation habit, for example, so that you get the synthesis of both modalities in terms of building neuroplasticity in the brain. Last question from Colin Foster. What are the first steps to legalizing sacred use of ayahuasca? I'm going to assume you mean within the context of the federal government. As some of you might know, in New Mexico and Oregon, the religious use of ayahuasca is now legal for certain church members. It's also legal in much of South America, for example, in Brazil, Peru, Colombia. In terms of the first steps to legalizing sacred use of ayahuasca, I think the easiest way to start making headway is to work with local officials who are in a position of authority that can help you start to get things passed on a city-by-city level or even on a state-by-state basis. The 2 cases that we have so far in Oregon and New Mexico, I believe that was a combined case that was taken to the Supreme Court and they won. They ended up winning. And that was largely pushed by Dr. Jeffrey Bronfman, who is an heir to the whiskey Seagrams. He's an heir. Yeah, his family started that. So he's very rich. So he put money forward to get ayahuasca legalized within a religious context for, I believe, the UDV. And that they have churches in Oregon and New Mexico. I may be slightly incorrect about that, but that's the general push. So if you want to legalize it nationwide, that's a good question. That's a really good question. I think there are various ways that you can go about it. I think the best way, though, is to start working with local and state-based officials and possibly setting up some sort of UDV in the states themselves and then trying to bring courses to the Supreme Court to see what happens. But again, that's just a thought. I'm no expert on the political policy sides of making these substances available. So guys, thanks so much for tuning in. A sneak peek for next week, we're having Rachel Harris on the show, author of Listening to Ayahuasca, and we talk about ayahuasca in that show. So just stay tuned next week. That's coming up.
Thanks for listening to the Psychedelia Podcast with Paul Austin. Want more psychedelic information? Go to our website at thethirdwave.co and register for our email list and newsletter. Also, please consider donating to The Third Wave via our Patreon page. Donations make this podcast possible. Psychedelics have the potential to transform lives. By donating, you enable us to continue to inform people about the benefits of these powerful substances.